Happy New Year! Oh, you're gonna do that every time, aren't you?
What's your subscriber count?
What's my subscriber count? Let's check. Let's check the sub count. Welcome, yeah, welcome back. Welcome back to my channel. I'm still at 61.
Oh,
What? I was at 61 yesterday. Come on, people.
Let me make sure I'm subscribed.
Let's step up our games here, okay? I told you we're having a subscriber session.
What are we doing?
100.
What are you doing for?
I don't know. It's a surprise. It's a surprise to me too.
I'll play the party.
Yeah, there you go. All right. So again, I talked about this a little earlier in class today. What we're going to look at now is what do we do if the zeros are non-real or irrational, and we want to try to get back to our polynomial. So something like this. Everybody should write this down. We're only going to do a couple of these today. Now, I'm going to teach this in two different ways. Okay, I don't care how you do it. The second way actually came from Mrs. Napol's. One day we were talking about how we were doing these problems. It was like 3 or 4 years after we started teaching this. The same during, we both started doing Algebra 2. She was like, I do this problem this way. And I was like, I do this problem this way. And we both liked each other's way. And so she actually teaches it the way I do now, but we both teach both ways just in case you guys, it works more, makes more sense in your heads. All right, so we've got 2 plus I, radical 3, and 1. Okay, so you know how we had the rational root theorem? The rational root theorem was the P over Q stuff, right? There is another thing called the irrational root theorem. It says that if you ever have an irrational root, and this also goes for complex roots, if you ever have an irrational root or a complex root, the conjugate is also a root. Okay? The conjugate is also a root. Guys, what is the conjugate of 2 plus I? 2 minus I. Remember, that's how conjugates work, right? So if you have 2 plus I, it's also 2 minus I. You can never have a conjugate pair. You can never have just one of a conjugate pair. You have to have both sets of the conjugate pair. So what do I mean by that? Well, if you know that 2 plus I is a root, 2 minus I must also be a root. Okay? If you know that positive radical 3 is a root, you also know that minus radical 3 is a root as well. Negative radical 3 is a root. That does not apply for the whole numbers. Okay, it only applies for irrational and complex roots. Okay, what should my final power on x be? Now that we have all of our roots shown to us, what should our final power on x be? 5. It looked like it was going to be 3, but we just added in 2 more. The negative I, the negative radical 3. Okay, so I know that I should end with 5, x to the 5th power, 5 degrees. All right, so this is the way I normally teach it. Okay, this is the way I like to do things. How do I solve this? Well, I've got to think about it like this. I've got to start getting things over toward the x, and I've got to get a 0 on the right side. So x minus 2 is equal to plus or minus I. And then I kind of deconstruct I, and I deconstruct the radicals. What I mean by that is that if I've got I, what is I? The square root of negative 1, right? So this is x minus 2 is equal to plus or minus the square root of negative 1. Well, how do I get inside the house? How do I undo a square root? No. Square the other side. I square the other side. So that means I would take an x minus 2 squared is equal to negative 1, right? How do I undo a square root? I take the square of the opposite side. Well, what does that require me to do with x minus 2? What do I have to do with this? Can I just distribute in the power? Heck no, I'll throw my marker at you. No, just kidding, I wouldn't do that. I don't throw things at students. X squared minus 4x, yeah, that's right, plus 4. Right, I just foiled that real quick. First is x squared, outer are both minus 2x's. Last outer and inner are both minus 2x's, and then last is negative 2 times negative 2, so positive 4. And then to finish it off, I add the 1 over to the left side. X squared minus 4x plus 5. Okay, now I've got it set equal to 0. That is my factor. That is my factor. I keep moving now. I've got x is equal to plus or minus radical 3. But now in this case, I don't have anything to add or subtract over in front of the radical 3. So I just square the opposite side, and this becomes a lot easier because now I just do x squared is equal to 3. Y'all follow me there? Subtract the 3 over to the other side. X squared minus 3 equals 0 is my factor. And life is good with my last one. It's just an x minus 1. And now at this point, I can say that my f of x is going to be, okay, f of x is going to be x squared minus 4x plus 5, x squared minus 3, x minus 1, x minus x, x minus 1. And now I just have to FOIL this out. I just have to FOIL out. I have to multiply it out, right? It just requires a little bit more work. Okay, so we're going to say, let's multiply those together. So x squared times x squared is x to the 4th. X squared times negative 3 is a negative 3x squared. Negative 4x times x squared is a negative 4x to the 3rd. Negative 4x times negative 3 is a plus 12x. 5 times x squared is a 5x squared. 5 times negative 3 is a negative 15. All still multiplied by x minus 1. So I'm just going to reduce inside the parentheses x to the 4th minus 4x cubed plus 2x squared plus 12x minus 15. All still multiplied by x minus 1. Okay, now I just multiply into the x minus 1. So x to the 4th times x is x to the 5th minus x to the 4th. Negative 4x to the 3rd times x is a negative 4x to the 4th plus 4x to the 3rd. 2x squared times x is a 2x cubed. 2x times negative 1 is a negative 2x squared. 12x times x is a 12x squared. 12x times negative 1 is a negative 12x. And then negative 15 times x is a negative 15x. And then negative 15 times 1, negative 1 is a plus 15. And now we just say equals, combine all like terms. Negative 5x to the 4th, a plus 6x cubed, a plus 10x squared, minus 27x plus 15. Now that was fun.
You just see the smile on all of
That was just fantastic.
What's your language? You're going to you on.
I know.
You could get flagged for that.
I could. All right. So, do we all see the process at least? Again, the goal is to, in the first part, there's really like 2 parts of this problem. In the first part of the problem, you try to find what your factors are. In the second part of the problem, you're taking your factors and you're remultiplying them together. The second part of the problem, from the line that I draw down, is the same with either method of solving this. Okay? From this part on down, I would do the exact same thing. To get the factors is where there's another method that you could possibly use. Let me, you know what, I'm going to show it. I better show it up here. I'm just going to copy this and get a new page. No, can't right click. Oh, I guess I can just do edit paste. No, I didn't undo. That's not what I wanted. I'll just I'll just clone it. All right, so, oh, that's why. What was that, radical 3 inside there? Okay, so what's the other method on doing this problem? Well, you can treat it like this. We know that x is equal to 2 plus or minus I, x is equal to plus or minus radical 3, and x is equal to 1. Now this guy over here, I mean, it's just a whole number, just bring it over. Okay, that does not change. What changes is when you have irrational and non-real roots. Because you can really separate this into x is equal to 2 plus I, and x is equal to 2 minus I, right? You can really separate this into x equals radical 3 and x equals negative radical 3. You follow me there? So what you can do is say, all right, well then that's x minus 2 minus I, x minus 2 plus I, x minus radical 3, and x plus radical 3. And now what you can do is multiply these two things together and then multiply those two things together. Okay? What I mean by that is if I take an x minus 2 minus I and an x minus 2 plus I, what's going to happen is the i's are going to cancel out. If I multiply this together, okay, multiplying my x's in, I get x squared minus 2x plus xi. Bring in the negative 2, negative 2x plus 4 minus 2I. And then bring in the negative I, you get negative xi plus 2I minus I squared. Right, all I did was just multiply those two trinomials together. Watch what happens. I get x squared, looks like minus 4x, and then that goes away. So we got this out of the way, this out of the way, this out of the way. It looks like I've got this cancels, this x positive xi and the negative xi cancel. The positive 2i and the negative 2i cancel. And then I'm ending up with a plus 4 and a minus I squared. Guys, what's I squared? Negative 1. So when I take I squared here, this is really just saying plus 1 because it changes the sign of that thing. Okay, 4 plus 1 is 5. Look back up at the work that we'd had before. X squared minus 4x plus 5. X squared minus 4x plus 5. You see that? So this is really just a different way to do that. Okay? I don't care which way you do it. Some people like this method better. I don't know. I think you're crazy. And then so if we had this, x minus radical 3 and x plus radical 3, you would just FOIL that out. You get x squared minus radical 3x plus radical 3x plus 3. No, sorry, minus 3. Minus 3. And then those would cancel because it's a difference of squares. X squared minus 3. It's a little bit easier when you don't have 3 terms. But whatever. And now from that point, you would multiply the x squared minus 4x plus 5, the x squared minus 3, and that x minus 1 that we had at the very beginning. Okay, let's do another one of these. This is the last problem in the notes today. These take a little time.
I guess like 4 of them on the whole.
1, 2, 3, 4, 5, 6.
Are they all B's?
No.
Okay.
Some of them are just whole numbers, and I think some of them are fine to zeros again. Just kind of keep it in your brains.
Oh, so I just calculate.
All right, 2i, 1 plus radical 2, and 3. So again, we know that if I've got x is equal to positive 2i, negative 2i is there as well. If I've got x is equal to 1 plus radical 2, the negative is there as well. You do not say that same thing for the whole numbers. The rational roots, I guess I should say. The rational roots. That is only for irrational and complex. Okay. So the plus or minus 2i. Now, when there's a number in front of the square root, my first method gets a little bit more difficult. Here's what I mean by that. Again, what we're doing is we're deconstructing the radical, right? So it's like plus or minus 2 radical negative 1. What you have to do is put that whole number, before you square the opposite side, you have to put that whole number back inside the radical. Okay? Again, this whole process is moving things backward, right? We're going backward toward the polynomial. So if I wanted to move this backward, I have to put that radical back underneath. I'm sorry, put that whole number back underneath the radical. So what would that be if I put that back underneath the radical? What would that 2 turn into? A 4 on the inside, right? Because a 4 on the inside of the radical would make a 2 on the outside of a radical, correct? So here's what we would need to say. This turns into x is equal to plus or minus the radical negative 4. Right? If there was a 3 on the outside of the radical, what would it turn into going back in? A 9. If there was a 6 outside the radical, what would it turn into going back in? A 36. Right? Okay. So because there was a 2 on the outside, it turns back into a negative 4. All right, and now at this point, I square the opposite side. X squared is equal to negative 4. So x squared plus 4 is my factor. I'll let you in on a little secret. Whenever you have 2 terms like this in your root, like this second one that we have, the 1 plus or minus radical 2, those are the hard ones. You're going to need to do some foiling for that. Here's what I mean by that. I have to subtract the 1 to isolate the radical. There's nothing outside the radical that I need to bring back in at this point. You know, if this was like 2 radical 2, I'd have to bring a 4 back in. If this was 3 radical 2, I'd have to bring a 3 back in for a 9 on the inside. But at this point, my radical is completely isolated. Everything's back inside the house. Now is the point where I square. X minus 1 squared is equal to 2. But I've got to FOIL that. Right? X minus 1 squared turns into x squared minus 2x plus 1. Right? My firsts are x times x, which is x squared. My outers and inners are both negative 1x to make the negative 2x in the middle. And my lasts are both negative 1. Negative 1 times negative 1 is a positive 1. So I subtract the 2 over to the other side. X squared minus 2x minus 1 equals 0. And that's the factor. These problems make the ones that just have whole numbers look like just a piece of cake, don't they? Bring me back some of those. So here's my f of x. X squared plus 4. X squared minus 2x minus 1. And an x minus 3. Okay, and now we multiply. So f of x turns into, leave room, folks, leave room. X to the 4th minus 2x to the 3rd minus x squared. Now bring in the 4 plus 4x squared minus 8x minus 4. Right? X to the 4th minus 2x cubed. Okay, good. Minus x squared, 4x squared, 8x, negative 8x minus 4. All right, still multiplied by, I know I got to reduce, but there. You know what? Why not? Here, just do this. This is that's a 3. It was negative 1 and positive 4, a 3x squared. All right, and now we multiply in. x to the fourth times x is x to the fifth. X to the fourth times negative 3 is a negative 3 x to the fourth. Negative 2x cubed times x is a negative 2x to the fourth. Negative 2x cubed times negative 3 is a plus 6x cubed. 3x squared times x is a 3x cubed. 3x squared times negative 3 is a minus 9x squared. Negative 8x times x is a negative 8x squared. Negative 8x times negative 3 is a plus 24x. Negative 4 times x is a negative 4x. Negative 4 times negative 3 is a positive 12. So we get as our answer x to the fifth minus 5x to the fourth plus 9x cubed minus 17x squared plus 20x plus 12. Well, that's fun. Yeah, here's what I'm going to say about those problems. Stay organized. Stay organized. You're going to have to kill some trees. Just space everything out. Stay organized. All right. Say so long, everybody.
So long.
Yeah.